This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. OpenZD is the only open source way to embed zero trust networking into your app, giving you unprecedented control and security. Give your app superpowers using an OpenZD SDK and a few lines of code. Never face the horrors of VPNs, DNS, or inbound ports. No networking engineering skills needed. OpenZD is trusted by developers at Microsoft, Oracle, and Ramco. If you don't want to host OpenZD, NetFoundry can with free plans at netfoundry.io/SERadio. That's netfoundry.io/SERadio.
Hello and welcome to Software Engineering Radio. My name is Nikhil and I'm going to be your host today. And today we are going to be talking to Omer Katz. Omer is a software consultant based in Tel Aviv, Israel. A passionate open source enthusiast, Omer has been programming for over a decade and is a contributor to multiple open source software projects like Celery, Mongo Engine, and Oplab. Omer currently is also a committer to the Celery project and is one of the administrators of the project. And he is the founder and CEO of the Katz Consulting Group. He supports high-tech enterprises and startups in Israel by providing solutions to software architecture problems and technical debt. Welcome to the show, Omer. And do you think I have covered your extensive resume, or do you feel that you need to add something to it?
Well, I'm married to a beautiful wife, Maya, and I have a son, a 2-year-old son, Itamar, which I'm very, very proud of. And it's very, very hard to work on open source projects when you have these conditions with the pandemic and, life.
Cool. Thanks, Omer. So to the topic of discussion today, we're going to be talking about distributed task queues and how Celery, which is a Python implementation of a distributed task queue, is set up, right? So we're going to do a deep dive into how Celery works. Just so that our audience understands, can you tell us what is a distributed task queue and for what use cases would one use a distributed task queue?
Right. So a task queue would be a fiction, in my opinion. A task queue is just a worker that consumes messages and executes code in consequence. It's a really weird concept to, use it as a type of software instead of as a type of architectural building block. Because
okay, cool. So you mentioned it is an architectural building block. Is the task queue just another name for a job queue?
Is a task queue? No, naturally no. You can use a task queue to execute jobs, but you can use a message queue to publish messages that aren't necessarily job. They could be just data or logs that are not actionable by themselves.
Okay. So from a simple perspective, so as a software engineer, can I think of a task queue sort of like a engine or a means to execute tasks that are not synchronous? So can I make it something about asynchronous execution of tasks?
Yeah, I guess that's the right description of the architecture component, but it's not really a queue of tasks. It's not a single queue of tasks. I think the term does not really reflect what Celery or other workers do, because the complexity behind it is not just a single queue. You have a one task queue when you are a startup with 2 people, but the right term would be a task processing framework, because Celery can process tasks from one queue, multiple queues. It can utilize the broker topologies the broker allows. For example, RabbitMQ allows fan out. So you can send the same task to different workers, and each worker would do something completely different as long as the function name, as the task's name is the same. You can create topic exchanges, which also work in Redis. So you can route a task to a specific cluster of workers which handle it differently than another cluster just by the routing key. Routing key is essentially a string that contains namespaces in it, and a topic exchange can provide a routing key as a glob. So you could exclude or include certain patterns.
Right. Okay. So let's dig into that a little bit. So just to contrast this a little bit more. So there is, when you talk about messaging, there are other models also in messaging, right? So for example, the actor model and actors that are running in an actor model. Can you tell us what would be the difference between the architectural pattern of an actor model and the one that we are talking about today, which is the task queue?
Yes. Well, the actor model has axioms where task execution platform or engine doesn't have any axioms. You can run whatever you want with it. One task can do many things or one thing. An actor maintains the single responsibility principle. It only does one thing and they communicate with each other. What Celery allows is to execute arbitrary code that you've written in Python asynchronously using a message broker. There are no real constraints or requirements to what you can or can't do, which is a problem because people try to run their machine learning pipelines with Celery when there are far better tools for the task.
Okay, cool. So as we see that a task queue, so given this, can you talk about some of the advantages, or why would you actually want to use something like Celery or a distributed task queue over, say, a simple job manager or a cron job of some sort?
Well, Celery is very, very simple to set up, which will always be the case because I think we need a tool that can grow from the startup stage to the enterprise stage. At this point, Celery is for the startup stage and the growing company stage, because after that, things start to fail or cause unexpected bugs because the conditions that the Celery is in is something that it was not designed for when the project started. I mean, you have to remember, we haven't dealt with this scale back in the day, even not in 2010.
Right. And yeah, so one of the things about Celery that I've noticed is that it is, like you pointed out, very easy to set up. And it is also not a single library, right? So it uses a messaging protocol or a message broker to kind of run the actual queue itself and the messaging itself. So Celery was built on top of this other library called Kombu. And as I understand it, Kombu is also a message, it's a wrapper around a messaging protocol called AMQP, right? So can we step back a little bit and talk about AMQP? What is AMQP and why is it a good fit for something like what Celery does?
Okay, AMQP is the Advanced Message Queuing Protocol, but it has two different protocols under that name. 0.9.1, which is the protocol RabbitMQ implements, and 1.0, which is the protocol that not many message brokers implement, but Apache ActiveMQ does, which we don't support. Celery does not support it yet. Also, QP Proton supports it, but we don't support that yet. So basically, we have a concept where there's a protocol that defines how we communicate with our queues. How do we route tasks to queues? What happens when they are consumed? Now, that protocol is not well defined, and it is apparent because RabbitMQ has an addendum as an errata for it. So things have changed, and what you read in the protocol isn't the reference implementation because RabbitMQ is. There were things that were not known when 0.9.1 was conceived, which, for example, is the replication of queues. Now, RabbitMQ introduced quorum queues very, very recently. In previous days, you could not keep a highly available RabbitMQ instance easily.
Right. Can we go a little bit more simpler about, okay, so why is Celery using a messaging protocol as opposed to, like you could just have some entries in a database or Redis can read from? Why messaging protocol?
Right. So AMQP guarantees delivery, at least once delivery. And that is a very, very interesting property for anyone who wants to run something asynchronously. Because otherwise, you'd have to take care of it yourself. TCP does not guarantee an acknowledgement at the application level. So the most fundamental thing about AMQP is that it was one of the protocols that allowed you to report on the state of the message. It is acknowledged because it's done. It's not acknowledged, so we return it to the queue. It can also be rejected and redelivered or not. And that is a useful concept because let's say, for example, Celery wants to reject a message whenever the message fails. That is helpful because you can then route the message to where messages go when they fail. So let's talk a bit about exchanges in AMQP 0.9.1, and I'll explain that concept further and why that's useful. So exchanges are basically where tasks land and decide where to go. You have a direct exchange, which just delivers the task to the queue it is bound on. You can create bindings between exchanges and queues. And if you bind a queue to a direct exchange and a message is received in that exchange, the queue will get it. You can have a fan-out queue, which is a fan-out exchange, which is how you deliver one message to multiple queues. Now, why is this useful in general? Let's imagine you have a social network with feeds. So you want everyone who is following someone to know that a new post was created. So you can rebuild their feed in the cache. So you can fan out that post to all the followers of that user from a fan out exchange that was created just for that user. And then after you're done, just delete all of the topology. That would cause the message to be consumed from each and every queue, and it would be inserted to each and every user's feed cache, for example.
Right, right. So that's a great point because that kind of allows one to see that Celery, which is built on top of this messaging library, can also be configured to support these types of scenarios, right? So you have a fan out scenario, or you have a pub sub scenario, or you have a direct queue consumption scenario. So it's not just that you have to have one Celery. So can we talk about a little bit about the Celery library itself? Because one thing I have noticed about it is that it has got a plugin architecture, right? So the Celery library itself has got plugins for the Celery beat, which is a scheduling option, and then it has Kombu. It has also got, you can also support multiple different types of backends. So maybe we can just step back a little bit and talk about the basic components that somebody would have to do, install or set up in order to implement Celery.
Well, if you implement Celery, you'd need a framework that maintains its different services logically. And that's what we have in Celery. We have had ad hoc framework for running different processes in the same process. So, for example, Celery has its own event loop that was written to make the communication with the broker asynchronous, and that is a component. And Celery has a consumer, which is also a component. It has gossip, mingle, etc., etc. All of these are pluggable. Now, we control the starting of stopping of components using bootsteps. So you decide which steps you want to run in order, and these steps require other steps. So you basically get an initialization DAG.
Okay. So we have the application, which would be our own application. We kind of import Celery into it. and then we have this message broker. Does this message broker have to be a RabbitMQ, or is there what are the other types of message backends that Celery can support?
We have many. We have Redis, we have SQS, and we have many more which are not very well maintained, so they're still in experimental state, and everybody is welcome to contribute.
Right, absolutely. So RabbitMQ obviously is the AMQP message broker, and it's probably the primary message broker. Does Redis also support AMQP, or how do you actually support Redis as a backend?
So unlike Celery, where there are a lot of design bugs and problems and abstraction problems, Combo's design is brilliant. What it does is that it emulates AMQP 0.9.1 logically in code. So we create a virtual transport with virtual channels and bindings. And since Redis is programmable, you can use Lua or you can just use a pipeline. Then you can just implement whatever you need within Redis. Redis provides a lot of fundamental constructs for storing messages in order or in some order, which provides you a way to implement it and emulate it. Now, do I understand the implementation? Partially, because the reality of an open source project is that some things are not well maintained, but it works. And there are many other task platforms, task execution platforms, which use Redis as the sole message broker, such as RQ. And they're a lot simpler than Celery.
Awesome. So obviously that means that I misspoke when I said Celery kind of supports RabbitMQ and Redis. It's basically standing on top of Combo, and Combo is the one that actually manages this. So I think we have kind of like a reasonable idea of what the various parts of Celery is, right? So can we maybe take an example, right? So to say, let's say I'm trying to set up a simple online website for my, a shop, right? So, and I want to kind of sell some basic clothing or some wares, right? And I want to also have this feature where I want to send a delivery order confirmation email, or there are various kind of notifications to my customers about the status of their orders, right? So assume that I've kind of like built this simple website in Flask, and now for these notification emails and notifications maybe by SMS, right? There are 2 or 3 different types of notification. I want to use Celery, right? So for this, right? So for this simple thing, maybe I've set it up in a Kubernetes cluster somewhere on a cloud, maybe Google or Amazon or something, and I want to implement Celery. What would you recommend is the simplest Celery setup that can be used to support this particular requirement?
So if you're sending out emails, you're probably doing that by communicating with an API, because there are providers that do it for you. And
yeah, something like Twilio or maybe MailChimp or something like that. Yes.
Yeah, something like that. So what I'd recommend is to use asynchronous I/O. Now, Celery provides concurrency by pre-forking, so you'd have multiple processes, but you can also use gEvent or Eventlet, which make task execution asynchronous by monkey patching the sockets. And if this is your use case and you're mostly I/O bound, what I suggest is starting multiple Celery processes in one cluster, which consume from the same message broker. And that way you'd have concurrency both on the CPU level and the I/O level. So you'd be able to deliver hundreds of thousands of emails per second, because it's just calling an API. And calling an API asynchronously is very, very light on the system. So there will be a lot of context switching between green threads, and you'd be able to utilize multiple CPUs by starting new processes.
So the way I understand, so then that means is that I'll set up maybe a new container or something in which I will run the Celery worker, and that will be reading from a message broker.
But if you mention Kubernetes, you can also autoscale based on the queue size. So let's say you have one Docker container with one process that takes one CPU, but it can only process 200 tasks at a time. Now, you set that as a threshold for the autoscaler, and it will just start new containers and process more. So if you have 350 tasks, all of them will be concurrent now. And then we'll shut down that instance once we're done.
Right. So as I understand it, the scaling will be on the Celery workers, right? And you will have, say, maybe one instance of the RabbitMQ or Redis or the message broker that kind of handles the queues, correct? So how do I actually post a message onto the queue? Do I have to use a Celery client, or can I just post a message somehow? Is there a particular standard that I need to use?
Well, the Celery has a protocol, an application protocol on top of AMQP, which it passes over the messages body. You can't just publish any message to Celery and expect it to work. You need to use Celery's client. There is a client for Node.js. There is a client for PHP. There is a client for Go. A lot of things are Celery protocol compatible, but most people have been using Celery for Python anyway.
Right. So from my Flask website container, I will install the Celery client module and then just post the task to the message broker, and then the workers will pick it up. So, okay, so suppose, let's take this example one step further, right? So suppose I've kind of gotten a little successful, I'm kind of tasting, and my website is becoming popular, and I would like to get some analytics on, say, how many emails am I sending, or how many times that how many orders people are actually making for a particular product. So I want to do some sort of analysis, and I decide, okay, fine, we will have a separate analysis with data warehouse or whatever, and I cannot build a solution. But now I have this asynchronous step where, in addition to creating the order in my regular database, I need to now copy that data over, or I need to transform the data over and extract it into my data warehouse, right? Do you think that is something that should be done, or that can be done with Celery, or do you think that's something that's not really suited for Celery, and a better solution might be kind of like a proper ETL pipeline?
Well, you can. In simple cases, it's very, very easy and even encouraged. So let's say you want to send a confirmation email and then write a record to the DB that says this email was sent. So you update the order with confirmation email sent. This is very, very, very typical. But performing intensive ETLs or queries that takes hours to complete is simply unnecessary. What you're doing essentially is hogging the capacity of the cluster for something that won't complete for a couple of hours and is performed elsewhere. So at the very least, you occupy one coroutine. What most users do is occupy one process because they use preform.
Okay. So basically what you're saying is that it is possible to run that. It's just that you will kind of start using up processes and kind of locking up some of your Celery availability into this. And so basically that might be a problem. Okay. So let's kind of get into a little bit of, okay, so we've been talking about the best case scenario so far, right? So what happens, okay, when, say, for some sudden reason, there was a sale on my website, and, Black Friday or something, and a whole lot of orders came in. And my auto scaling kind of went started putting up a lot of Celery workers, and it reached the limits that are set by my cloud provider, right? So my cloud provider basically the Kubernetes cluster started killing and evicting the pods. So what actually happens when a Celery worker is killed externally, right? So it is kind of running out of memory and gets killed. And what kind of recovery or retries are possible in these kind of scenarios?
Right. So when Celery is killed, generally speaking, it is entered a warm shutdown phase, where it gives a timeout for all tasks to complete and then shuts down. But Celery also has a cold shutdown, which says kill all tasks and exit immediately. So it really depends on the signal you send. If you send say quit, you get a cold shutdown. And if you send sig int, you'll get a warm shutdown. If you send sig int twice, you'll get a cold shutdown instead. Which makes sense because usually you just click Control-C twice. You want to exit Celery when it's running in the foreground. So when Kubernetes does this, it also has a timeout on when it considers the container to be shut down gracefully. So you should be setting that to the timeout that you've set for Celery's warm shutdown, or give it even a little buffer of a few more seconds, just so you won't get the alerts because these containers were shut down improperly. And if you don't manage that, it will cause alert fatigue and you won't know what's happening in your cluster.
Right. So, but what actually happens to the task? So if it is, say, a long-running task, for example, does that mean that the task can be retried, or is what actually the guarantees that Celery provides?
Yeah, it does mean it can be retried, but it really depends on how you configure Celery. Celery by default acknowledges tasks early. It's a reasonable choice for early 2000s and 2010, but nowadays having it the other way around where you acknowledge late has some merits. So late acknowledgements are very, very useful for creating tasks which can be requeued in case of failure or if something happened, because you acknowledge the task only if it is complete. You acknowledge early in case where the task execution does not matter. You got the message and you acknowledged it and then something went wrong and you don't want it to be in the queue again.
Mm-hmm. So if it's not idempotent, right, that would be kind of something that you want to acknowledge early.
Yeah, and the fact that Celery chose the default that makes tasks not idempotent, allowed to be not idempotent, is, in my opinion, a bad decision. Because if tasks are idempotent, they can be retried very, very easily. So I think Celery should encourage that by design. So if you have late acknowledgement, you acknowledge the task by the end of it, if it fails or if it succeeds. And that allows you to just get the message back in case it was not acknowledged. So RabbitMQ and Redis has a visibility timeout of some sort. And they use different terms, but they have a visibility timeout where the task is still considered, where the message is still considered delivered and not acknowledged. After that while, it returns the message to queue back and it says that, you can consume it. Now, RabbitMQ also has something interesting when you just shut down a connection. So when you kill Celery, you shut down the connection and you shut down the channel the connection was bound to, which is the way for RabbitMQ to multiplex messages over one connection.
Right. So the fan out scenario.
No, not the fan out scenario. In the NQP, you have a connection and you have a channel. Now, you can have one TCP connection, but a channel multiplexes that connection for multiple queues. So logically, if you look at the channel, logically, it's like a virtual private network, like a VPC.
Right. Okay. So you're kind of like tunneling through the same TCP connection. You're sharing it between multiple queues. Okay. Understood.
Yeah. So when you close the channel, RabbitMQ remembers which tasks were delivered to that channel, and it immediately pops it back.
So it will then kind of make it appear. So if you have, say, for whatever reason, if you have, say, multiple workers on multiple machines or multiple Docker containers, say, and one of them is killed, then what you're saying is that RabbitMQ knows that, okay, that channel has died or closed, and it remembers the tasks that were on that channel, pulls that and puts it on the other channel so that the other worker can work on it.
Yeah, this is called a knock, where a message is not acknowledged. If it's not acknowledged, it's returned back to the queue it originated from.
Right. Awesome. So you said that there is a similar visibility mechanism for Redis as well, correct?
Yeah, not similar because Redis does not really have channels. And we do not track which tasks we delivered where, because that could be disastrous for the scalability of the system on top of Redis. So what we do is only provide a timeout, a maximum timeout. This is also relevant in SQS as well because both of them has the same concept of visibility timeout, where if the task does not get processed after, let's say, 360 seconds, it's returned back to the queue. So it's a basic timeout.
Timescale DB from your friends at Timescale is the leading open source relational database with support for time series data. Time series data is timestamped so you can measure how a system is changing. Time series data is relentless and requires a database like Timescale DB with speed and petabyte scale. Timescale DB is the Postgres you know and love with time series superpowers. Familiarity, flexibility, speed. That's Timescale. Visit them today at tsdb.co/SERadio. That's tsdb.co/SERadio.
Right. So is that something that as a developer, so in my earlier scenario, say suppose we were doing an ETL as well as the notification. Notifications usually will happen quickly, whereas an ETL can take, say, a couple of hours as well. So is that a case where we can go to Redis or we can configure in Celery that, hey, for this type of task, increase the visibility timeout so that it doesn't... Okay.
No, unfortunately, no. Actually, that's a good idea, but what you can do is create two Celery processes which have different configurations. And I'd say, actually, that these are two different projects with two different code bases, in my opinion.
Right. So you would basically separate them into two workers. One worker that is just handling the long-running tasks and the other worker that doing the notifications. Okay, cool. So obviously when there are failures and when there are things like this, you obviously also want to have some kind of visibility into what is happening inside a Celery worker, right? So can you talk a little bit about how we can monitor tasks and how maybe there are logging in tasks are done?
Currently, the only monitoring tool we have is Flower, which is another open source project that listens to the events protocol Celery publishes to the broker and gets the metadata from there. But basically, the result backend is where you monitor how tasks are going. You can report the state of the task. You can provide custom states. You can provide progress, context, whatever context you have to the progress of the task. And that could allow you to monitor it with an external system that just listens to changes, just like Flower. If, for example, you'd have something that translates this to StatsD, you could have monitoring as well. Celery is not very observable. One of the goals of Celery Next Gen would be to integrate it completely with Open Telemetry. So it will just provide a lot more data into what's going on. Right now, the only monitoring we provide is through the event system. You can also inspect to check the current status of a Celery process. So you can see how many active tasks there are. You can get that in JSON too. So if you do that periodically and push that to your logging system, maybe you can make data views.
Awesome. Okay. So obviously, if you don't have that much visibility in monitoring, how does actually Celery handle logging? So is it possible to kind of extend the logging of Celery so that we can add more logging to maybe try and see if we can get more data information out of on what is happening from that perspective?
Well, logging is configurable as much as Django's logging is configurable.
Okay. So it's like general extension of the Python logging libraries.
Yeah, pretty much. And one of the things that Celery does is that it tries to be compatible with Django. So it can take the Django configuration and apply it to Celery for logging. And that's why they work the same way. As far as logging more data, that's entirely possible because Celery is very extensible when it's user-facing. So you could just override the task class and override the hooks before start, after start, stuff like that. You could register to signals and log data from the signals. You could actually implement OpenTelemetry, and I think in the contrib package of OpenTelemetry, there is an implementation for Celery. Not sure what's the state right now. So it is entirely possible to do that. It's just that it wasn't implemented yet.
So it's not kind of like native to Celery per se, but it provides extension points and hooks so that you can implement it yourself as you see fit. Okay, cool. So moving on to a little bit more about how to scale a Celery implementation. Earlier you had mentioned and you had said that, hey, Celery is a good option for startups, and then it grows. But as you grow, you start seeing some of the problems or the limitations of a Celery implementation, right? Obviously, when you're in a startup mode and you're a developer there, you want to kind of maximize the usage of whatever choice you made. So if you made Celery choice, then basically you would want to first try to see how far you can take it before then you go with another alternative. So what are the typical bottlenecks that usually occur with Celery, right? What is the first thing that kind of starts failing, or what are the first warning signs that your Celery setup is not working as you thought it would be?
Well, for starter, very large workflows. Celery has a concept of canvases, which are building blocks for creating a workflow dynamically, not declaratively, but by just composing tasks together ad hoc and delaying them. Now, when you have a very large workflow, a very large canvas that is serialized back into a message broker, things get messy because Celery's protocol was not designed for that scale. So it could just turn up to be 10 gigabytes or 20 gigabytes, and it will try to push that to the broker. We've had an issue about it, and I just told the user to use compression. Celery supports compression of its protocol, and it's something I encourage people to use when they start growing from the startup stage to the growing stage and have requirements that are not up to what Celery was designed for.
So when you say compression, what exactly does that mean? Does that mean that I can actually take a Celery message and zip it and send it, and they will automatically pick it up?
Yeah.
Oh, awesome. Right. Okay, cool. So if your message size becomes too large, or if you've got too many parameters in your message, like you said, you're creating a canvas or it's a set of operations that you're trying to do, then you can kind of zip it up and then send it up. That's interesting. I did not know that. That's very interesting.
Another thing is trying to run machine learning pipelines, because machine learning pipelines, for the most part, use prefork themselves in Python to parallelize work. And that doesn't work well with prefork. It sometimes does, it sometimes doesn't. Billiard is voodoo to me, and it's very much not documented. Billiard is Celery's.
So just tell me what Billiard is.
Yes, Billiard is Celery's implementation of multiprocessing. It's support that allows you to support multiple Python versions in the same library with some extensions to it that I really don't know how they work. Billiard was the component that was never ever documented. So the most important component of Celery right now is something we don't know what to do with.
Right. Interesting. So Billiard essentially would be something that you want to use if you want to kind of, if you have some components that are for different Python version, or if they are not standard kind of implementations.
Yeah. JobLib has a similar project called Locky, which does a very, very similar thing. And I've actually thought about dumping Billiard and using their implementation, but that would require a lot of work. And given that Python has now a viable way to remove the global interpreter lock, then maybe we don't need to invest that much in prefork anymore. Now, for those who don't know, Python and Ruby and Lua and Node.js and other interpreted languages have a global interpreter lock. This is a singular mutex which controls the entire program. So when two threads try to run Python bytecode, only one of them succeeds because a lot of operations in Python are atomic. So if you have a list and you append to it, you expect that to happen without an additional lock.
Right. How does that kind of affect Celery? Is that basically one of the reasons why we're using an event loop for reading from the message queue?
Yeah, that's one of the reasons for using an event loop for reading from the message queue, because we don't want to use a lot of CPU power to pull and block.
Right. And that's also probably why we Python, in the Celery implementation, you favor process forking versus threads in the. Okay, cool.
So apparently having one mutex is better than having infinite amount of mutexes, because for every list you create, you'll have to create a lock to ensure all operations that are guaranteed to be atomic, and it's at least one lock. So removing the GIL is very, very hard, and someone found an approach that appears very, very promising. I'm very much hoping that Celery could by default work with threads, because it will simplify the code base greatly, and we could leave pre-forking as an extension for someone else to implement.
Okay, awesome. Right. So obviously we talked about these kind of bottlenecks that we are seeing over here, and we obviously know that the GIL or the threading approach is simpler. Other than Celery, obviously we've kind of referred to, there are other approaches to doing this particular task, right? So the whole idea of message queuing and task execution is not new. We have other orchestration tools, right? There are things called workflow orchestration tools. In fact, I think some of them, in fact, use Celery as well. Can you maybe talk a little bit about what is the difference between a workflow orchestration tool and a library like Celery?
So Celery is a lower level library. It's a building block of those tools because, as I said, it's a task execution platform. You just say, I want this task to be executed, and at some point it will, and if it won't, you'll know about it. So these tools can use Celery as a building block for publishing their own tasks and executing something that they need to do.
On top of that.
Yeah, on top of that.
Okay, cool. So given that there is these options like Airflow and Luigi, which are a couple of the workflow orchestration tools, we talked about the canvas object, right, where you can actually do multiple tasks or kind of orchestrate multiple tasks. Do you think that it might be better to maybe use these higher level tools to do that kind of orchestration, or do you feel that it's something that can be handled by Celery as well?
I don't think Celery was meant for workflow orchestration. The canvases were meant to be something very, very simple. You want each task to maintain the singular responsibility principle. So what you do is just separate the functionality we discussed for sending a confirmation email and updating the database to two tasks. And you launch a chain of the sending of the email and then updating the database. That helps because each operation can be retried separately. So that's why canvases exist. They were not meant to run your daily BI batch jobs with 5,000 tasks in parallel that return one response.
Right. Understood. Great. So that's obviously, like we said, I think we've talked about machine learning is not something that is a good fit with Celery.
Regarding Apache Airflow, did you know that it can run over Celery? So it actually uses Celery as a building block, as a potential building block. Now, Dask is another system that is related more to NumPy that can also run in Celery, because JobLib, which is the job runner for Dask, can run tasks in Celery to process them in parallel. So many tools actually use Celery as a foundational building block.
Right. So Dask, if I'm not mistaken, is also, I think, a task parallelization. It's a way to kind of break up your process or your machine learning thing into multiple parallel processes that can run in parallel. So it's interesting that it uses Celery underneath it. So it kind of gives you kind of like this idea that, okay, as we kind of go up and become more sophisticated in our workflows and in our pipelines, that there are these larger constructs that you can probably build on top of Celery that kind of handle that. So one kind of different thought that I was thinking about when looking at Celery was the idea of event-driven architectures, right? So there are entire architectures nowadays that basically are driven around this idea of, okay, you put an event in a bus or in a queue, or you have some kind of broker, and everything is events, and you basically have everything's kind of resolved as you go through all these events. So maybe let's talk a little bit about, is that something that Celery can fit into, or is that something that is more better handled by a specialized tool, say like maybe an enterprise service bus or something like that?
I don't think anyone thought it could, but it can. So as I mentioned regarding the topologies, the message topologies that MQP provides us, we can use those to implement an event-driven architecture using Celery. You have different workers with different projects using the same task name. So basically, when you just delay the task, when you send it, what will happen will depend on the routing key. Because if you bind two queues to a topic exchange and you'll provide a routing key for each one, you'd be able to route it to the right direction and have something that responds to an event in a certain way just because of the routing key. You could also fan out, which is, again, a user posted something, and then, well, everybody needs to know about it. So in essence, this task is actually an event, but it's still treated as a job instead of as an event. This is something I intend to change. In enterprise integration patterns, there are 3 types of messages. The enterprise integration patterns is a very, very good book about messaging in general. It's a little bit outdated, but not by very much. It's still relevant today. And it defines 3 types of messages. You have a command, you have an event, and you have a document. A command is a task. This is what we're doing today. An event is it describes what happened. Now, Celery, in response to that, should execute multiple tasks. So when Celery gets an event, it should publish multiple tasks to the message broker. That's what it should do. And document message is just data. This is very, very common with Kafka, for example. You just push the log, the exact log line that you received, and someone else will do something with it, who knows what. Maybe they'll push it to Elasticsearch, maybe they'll transform it, maybe they'll run analytics on it. You don't care, you just push the data. And that's also something Celery is missing, because with these 3 concepts, you can define workflows that do a lot more than what Celery can do. So if you have a document message, you essentially have a result of a task that is modeled in messaging terms. So you could send the result to another queue, and there would be a transformer that transforms it to a task that is the next in line for execution within the workflow.
Right. Okay. So you could basically create hierarchies of Celery workers that kind of handle different types of things, right? So you have one event that comes in, and that kind of triggers one Celery worker, which then in turn broadcasts more events or more tasks, and then that is kind of picked up by others. Okay, very interesting. So that seems to be a pretty interesting kind of thing towards kind of implementing event-driven architectures. To be honest, it sounds like it's something that we can do very simply without actually having to buy or invest in a huge message queuing or an enterprise service bus or something like that. And it sounds kind of a great way to kind of check out or try to experiment with event-driven architectures. So just to kind of loop back a little bit to our earlier in the beginning when we talked about the difference between actors and Celery workers, right? And we mentioned that, hey, an actor basically is a single responsibility principle. It does a single thing and it sends one message. Another interesting thing about actors is the fact is that they have supervisors and they have this whole entire hierarchy where you know when an actor dies or when something happens, it kind of has a way to automatically restart the thing. Are there any kind of thoughts or design ideas around doing something like that for Celery? Is there kind of like a way to say, okay, I'm monitoring my Celery workers, this worker goes down, or this particular task is not running appropriately, can I restart it or can I create a new worker? Or is that something that we kind of right now, I know you mentioned that we can have Kubernetes do that during the worker shutdown, but then that assumes that the worker is shutting down, right? If it's not shutting down or it's just stuck or something like that, then how do we kind of handle that?
If the process is stuck?
Yeah, if the process is, maybe it's running for too long or if it's running out of memory or something like that, maybe we want to preemptively.
You can limit the amount of memory each task takes, and if it exceeds it, the worker goes down. You can say how many tasks you want to execute before a worker process goes down. And you can retry tasks. That is, if a task fails and you've configured retry, and you've configured automatic retries, or just explicitly call retry, you can retry a task. That is entirely possible.
Okay. Within the task itself, you can kind of specify that, okay, this task needs to be retried if it fails.
Yeah, you can retry for certain exceptions or explicitly call retry by binding the function, but just say bind equals true, and you get the self of the task instance, and then you can call the tasks classes methods of that task. So you can call just call retry. There's also another thing about that I didn't mention: replacing. In 4.4, I think, someone added a feature that allows you to replace a canvas mid-flight. So let's say you decided not to save the confirmation in the database, but instead, since everything failed and you haven't sent a single confirmation email just yet, then you replace that task with another task that calls your alerting solution, for example. Or you could branch out, essentially. So this gives you a condition. If this happens, run for the rest of the canvas, run this workflow or task. Else, run this workflow for the end of the task. Right. So we were talking about actors. Celery had an attempt to write an actor framework on top of the existing framework. It's called Cell. Now, it was just an attempt. No one developed it very far, but I think it's the wrong approach. Celery was designed with an ad hoc framework that had patches over the years. And it's almost actor-like, but it's not. So what I thought was that we could just create an actor framework in Python that will be de facto a go-to actor framework in Python for backend packages. And that framework would be easy enough to use for occasional contributors to be able to contribute to Celery. Because right now, the case is that in order to contribute to Celery, you need to know a lot about the code and how it interacts. So what we want is to replace the internals, but keep the same public API. So if we bump a major version, everything still works.
Right. Awesome. That sounds like a great approach.
Yeah, that is a great approach. It's called Project Jumpstarter. The repository can be found in Celery's organization, and you're more than welcome to contribute. Would you like me to speak a little bit more about the idea or not?
Absolutely. So I was just going to ask, so is there a roadmap for Jumpstarter, or is this something that is still kind of in the early thinking or prototyping phase?
It's still in the early prototyping, but there is a direction where we're going. The focus is on observability and ergonomics. So you need to be able to know how to write a DSL, for example, in Python. Let me give you the basic concepts of Jumpstarter. Jumpstarter is a special actor framework because each actor is modeled by an hierarchical state machine. In a state machine, you have transitions from A to B and from B to C and C to E, etc., etc., etc. Or from A to Z, skipping all the rest, but you can't have conditions for which state can transition to which another state. In a hierarchical state machine, you can have state A, which can only transition to B and C because they're child states of state A. And you can have state D, which cannot transition to B and C because they're not children state.
Right. Okay. So it's kind of like a directional, almost like a directed acyclic graph.
Not child states of D. That was it, not A.
Yeah. No. So it's almost like a directed acyclic graph, right? So it's essentially.
Yeah, exactly.
Yeah. Okay. Cool. So.
But it's a directed acyclic graph that you can attach hooks on. So you can attach a hook before the transition happens, after the transition happens, when you exit the state, when you enter the state, when an error occurs. So you can model the entire life cycle of the worker using the state machine. Now, the basic definition of an actor has a state machine with a life cycle in it. Just batteries included. You come with batteries included. You have the state machine already configured to starting and stopping itself. So you have a start trigger and a stop trigger. You can also change the state of the actor to healthy or unhealthy or degraded. You could restart it, and everything that happens through the state machine. Now, on top of that, we add two important concepts. The concepts of actor tasks and resources. Actor tasks are tasks that extend the actor's state machine. You can only run one task at a time. So what that provides you is essentially a workflow where you can say, I'm polling for data, and once I am done polling for data, I'm going to transition to processing data. And then it goes back again to polling data because you can define loops in the state machine. It's Turing complete. It's not actually a DAG. It's a graph where you can make loops and cycles and essentially model any programming logic you want. So basically, the actor does not violate the basic three axioms of actors, which is having a single responsibility, having the ability to spawn other actors, and message passing. But it also has this new feature where you can manage the execution of the actor by defining states. So let's say when you are in degraded state, because the actor's health check that checks S3 fails. So you can't do anything, but you can still process the tasks that you have. So this allows running the poll tasks from the degraded state, but you can transition from degraded to processing data. So that models everything you need. Now, in addition to that, I've managed to create an API that manages resources, which are context managers, in a declarative way. So you just define a function, you return a context manager or an async context manager, and decorate it with a resource, and it will be available to the actor as an attribute, and it will be automatically cleaned when the actor goes down.
Okay. But one question I have was that, so you mentioned that this particular model will be built or jumpstarted without actually changing the major API of Celery, right? So how does this kind of map into a task? So does it mean that, okay, the app.task basically, or the classes that we have will remain unchanged, and they kind of like map into actors now instead of just functions?
So Celery has a task registry, which registers all the tasks in the app, right? So this is very easy to model. You have an actor, which defines one unit of concurrency and has all the tasks Celery is registered to in the actor. And therefore, when that actor gets a message, it can process that task and it's busy. You know it's busy because it's in the state the task is in.
Okay. Right. So it's almost like you're building a signaling of the whole framework itself. The context in which the tasks run is now basically inside the actor. And so now the actor model on top then allows you to kind of understand the state of that particular processing unit, right? Okay, that's great. That's awesome. So is there anything else that we have not covered today that you'd like to talk about in terms of the topic?
Yeah, it's been very, very hard to work on this project during the pandemic. And if I were to do it without the support of my clients, I'd have much less time to actually give the attention this project needs. This project needs to be revamped, and we'd very much like you to be involved. And if you can be involved and you use Celery, please donate. Right now, we only have a budget of $5,000 a year or $5,500, something like that. And we would very much like to reach a budget that allows us to put more resources in. So if you have problems with Celery, or if you have something that you want to fix in Celery or a feature to add, you can just contact us. We'd be very much happy to help you with it.
Awesome. So in terms of that, so that's a great point. How can our listeners get in touch about the Celery project? Is that something that is there in the main website regarding this donation aspect of it or the sponsoring aspect of it?
Yes, it is. And you can just go to our Open Collective or to our GitHub repository. We have set up the funding from there.
Right. So awesome. In that case, then when we post this onto the Software Engineering Radio website, I'll make sure that these links are there and that our listeners can access them. So thank you very much, Omer. This was a very enjoyable session. I really enjoyed speaking with you about this. Have a great day.
You too.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.